that you're starting to get the idea of the arithmetic sequences and constant difference, I want to look at two more examples. Again, we're going to consider, is this an arithmetic sequence? If so, what is its constant difference? Once we have that, we want to consider, is it a direct variation equation? If so, then can we write the equation? All right, so let's go ahead, and I'm going to show you yet one more way to check whether it's direct variation or not. All right, so let's go ahead and start with the first one. What are the next three terms? Hopefully you recognize that each time we're going minus 4, minus 4, minus 4. All right, so we end up getting negative 11, negative 15, negative 19. So the constant difference is negative 4, because each time I'm adding negative 4 or subtracting 4. Is this an arithmetic sequence? Absolutely, because it has a constant difference. If there is a constant difference, it's arithmetic. That's all there is to it. Next question, is this sequence demonstrative of direct variation? Okay, well, let's look. If we take the points and we put them into a table, which is one way to do it, we can do the first term, the second term, the third term, the fourth term. I'll just go with 4 terms this time. 5, 1, negative 3, negative 7. So we'll put those down. So 1, comma 5, 2, comma 3. Not just kidding. 2, comma 1, 3, comma negative 3, and then 4, comma negative 7, which will be off my graph. Okay, so ignoring the point that I was completely wrong on, let's draw our graph. You'll notice that it is a straight line. So it is linear, but is it direct variation? No, it's not. Now, we can check that, of course, by using our y equals kx. Maybe I graphed it wrong, right? So let's just check. So y equals kx. K is the slope. The slope is the constant difference. So y equals negative 4 times x, and I can just choose any point, so we'll choose 5 and 1. So this is the point we'll test. 5 equals negative 4 times 1. 5 is definitely not equal negative 4. Therefore, again confirmed, not direct variation. Now, the other thing that you can do, we know that direct variation, which is what we're looking for, is the same thing as proportional. So we could also do a proportion. So we actually have 3 different ways of checking whether this is direct variation or not. The first one being looking at the graph, using the slope. The second one being check using the direct variation equation. Third, we can draw a proportion. If it is direct variation, it will be proportional. So I'll put my y values on top, my x values on bottom. Can you do it opposite? Absolutely. You can put x on top, put y on bottom. So here's 1 point, 5 and 1. That's this one. And then the other point, 1 over 2. You can tell already this is not going to be equal. If you cross multiply, you got 10 equals 1. Whatever! Not going to happen. So again, proving not direct variation. Any one of these is acceptable. All right, let's go here to the side and let's look a little bit more at one more example. Okay, so the example that I have here, what is the pattern? What would the next terms be? Hopefully you recognize that we're multiplying by 2 each time. Okay, so of course it would be 16, 32, and 64. Okay? You don't really even need to graph this to be able to see that this is no way even going to be linear, right? The first term is 1. The second term is 2. Oh, that could be linear, but then the third term all of a sudden is 4. And the fourth term, oh my goodness, the fourth term is all the way up at 8. That ain't linear, my friends. The end.